Today we're going to look at section 1.4. Section 1.4's title is Rational Expressions. Now we've talked about rational numbers. So rational is like another way of saying a fraction. But in this case, we're going to have a fractional expression where both the numerator and the denominator are polynomials. Okay, so we're going to have a rational expression where the top, the numerator, and the bottom, the denominator, are polynomials. The first thing we're going to look at is the domain of an expression. Now, when we're looking at the domain, we're looking first for the restrictions. So if we can find out what things we cannot have, then the rest of the stuff becomes our domain. So the first restriction we're going to look at is in a fraction or a rational expression, the denominator. Now we said the denominator was the bottom part of the fraction, so the denominator cannot equal 0. Because we know that we can't have 0 in the bottom of a fraction. The second restriction we're going to look at has to do with a radical. So if I have a radical sign, this number that's underneath the radical is called the radicand. And what do we know about that number under the radical sign? Well, we know that that number has to be greater than or equal to 0. So the radicand has to be greater than or equal to 0. So these are the two restrictions. So if I look at an example, again, we're finding the domain, 2x squared plus 3x minus 1. Now, this one is not a rational expression, but this one is just a polynomial. But what restrictions do we have? We don't have a denominator, and we don't have a radical. So, do we have any restrictions? Since there's no restrictions, then our domain is going to be negative infinity to infinity, all real numbers. Because we don't have the restrictions. But if I look at a rational expression, an example, so in this one I'm looking at a rational expression, x over x squared minus 5x plus 6. So this does have a denominator, so we have x squared minus 5x plus 6 cannot be 0. So what do we have to do to find out what x's make that not equal to 0? Well, what we're going to do is we're going to take and we're going to factor this into two sets of parentheses. So it's kind of doing FOIL in reverse. The first two have to multiply to be the x squared, so this is going to be x and x. The last two have to multiply to be a positive 6, but we know that the factors of 6 have to add to be 5. So we've got 3 times 2. Since this is a positive 6, they're either both positive or both negative. So in our case, since it's a negative 5, we're going to have a negative 2 and a negative 3. Now, we say that this cannot be equal to 0. So x minus 2 cannot be 0. And x minus 3 cannot be 0. So if I add 2 to both sides, I get x cannot be 2. And then over on this side, add 3. I get x cannot be 3. Now again, these are our restrictions. So if we have a restriction, we're going to put this on number line. So this number line would indicate all real numbers. except we can't have 2 and we can't have 3. Now, if we can't have it, how do we write that on a number line? We know that we can't have 2, so we're going to use an open circle on 2, which means that it doesn't have a 2, and an open circle on 3 because it can't be 3. But it can be everything else. The x in the numerator is not a restriction, so we know that we can do everything else besides 2 and 3 then. So how do we write this number line then in interval notation? So we're looking for the domain to be, starting here, going to the left forever would be negative infinity to 2. But now at 2 we don't include 2. So how do we do that in interval notation? We use a parentheses instead of a bracket. Union with between 2 and 3. So again we've got parentheses 2 to 3 parentheses. Then we've got this right hand side would be union parentheses 3 to infinity. And that would be our domain. So give everybody a chance to get caught up to that point. And then we're going to try another one. So example. So we have another x minus 2 over square root of x minus 7. So we've got a rational expression. This time we do have a denominator. So we're going to say square root of x minus 7 cannot be 0. And we also know that this inside here, the x minus 7 cannot be negative. So we're saying that x minus 7, the radicand, has to be greater than or equal to 0. But we know that it can't be equal to 0 because it's in the denominator. So instead, we're looking at x has to be greater than 7. So x cannot be 7 because x minus 7 cannot be 0. Adding 7 to both sides, x cannot be 7. So that's why we took away the equal sign. So when I added this plus 7 to both sides, instead of saying x is greater than or equal to 7, then we could just have x is greater than 7. So when we graph that, we have 7. It can't be equal to 7, so we have an open circle, and x greater than 7 is going to be everything to the right. So now when we write our domain in interval notation, we're starting with 7, but it's an open circle, so it's parentheses, 7 to infinity. The next thing we're going to look at is simplifying rational expressions. Now, when we simplified a fraction, we look to see what factors were in common with the numerator and the denominator, because anything divided by itself would be 1. So we have an example, x squared minus 1 over x squared plus x minus 2. So we have to factor the numerator and factor the denominator before we can do any canceling. So we can't cancel x squared and x squared because there's a plus and a minus between them. But we can factor first. So we get x times x to be x squared, 1 times 1 to be 1, but then now that's a negative 1 this time, so we're going to have 1 positive and 1 negative. So now with this other one, we have x and x. We're looking for factors of 2 that subtract now because it's a negative 2 to be a positive 1. So we know that this is going to be 2 and 1. Since the 1 is positive, subtract and take the sign of the larger, so the larger one has to be the plus, and this one has to be the minus. So we can see that in this case right here, the x minus 1 divided by x minus 1 is just going to divide out to be 1. So now we have x plus 1 over x plus 2 as a simplified rational expression. Be careful not to try to cancel out those x's because the plus and minus is in between. Okay, let's try another example. X squared plus 2x minus 3. X squared plus 8x plus 16. And then we have 3x plus 12 and x minus 1. Now notice what have I done here? I'm multiplying two rational expressions. So again, in multiplication, we don't have to have the common denominator like we do in addition. So I'm still going to start out with factoring. So factoring the numerator and the denominator. But now with this one, we don't have a squared term, so we're not going to use two sets of parentheses. But what we do see is we have a greatest common factor between 3x and 12, which would be a 3. So we're going to distribute out a 3. And the x minus 1 just comes down. So x times x to be x squared. 3 is a negative, so we know that factors of 3 that subtract to be 2 are going to be 3 and 1. Again, since we have a positive 2, then we know the positive 3, subtract and take the sign of the larger, so positive 3 minus 1 would give me 2x. The next one on the denominator, I've got x and x. Factors of 16 that add to be 8 would be 4 and 4. Since it's plus plus, then this has to be plus plus. So when we take the 3 out, we distribute a 3 out of here, we have x. Distribute a 3 out of the 12, we have 4. So now you're looking at the numerator and the denominator to see if there's any common factors that can divide out. So x minus 1 can divide out with x minus 1 and be a 1. X plus 4 can divide out with x plus 4. So we're left with 3 times x plus 3 over x plus 4. Again, let's give everybody a chance to catch up to that point first. Okay, so next one we're going to do is a divide. So we have x minus 4 over x squared minus 4 divided by x squared minus 3x minus 4 over x squared plus 5x plus 6. Now, what do we know about dividing two fractions? We know dividing is the same thing as multiplying by the reciprocal. So I've got x minus 4 over x squared minus 4 times this second one we're going to flip over. So multiplying by its reciprocal would be x squared plus 5x plus 6 over x squared minus 3x minus 4. So now we're back to the previous example. So we're going to factor. X minus 4 is going to stay the same, but this bottom part, difference of two squares. I've got x and x. 2 times 2 gives me 4, but I'm looking for a negative 4, so one has to be positive and one has to be negative. Now we always want to check the middle term. So this is positive 2x and negative 2x would cancel each other out. So that's why there's no middle term. So in the numerator, we've got x and x. Again, we've got a positive 6, so we know that's going to be 2 times 3 to be 5. Plus plus means this is plus and this is plus. So 2x and 3x would give me my 5x from my middle term. X and x, 4 is negative. So we're looking for factors of 4 that subtract to be 3. So we've got 4 and 1. Since the 3 is negative, subtract and take the sign of the larger. So we know the 4 has got to be negative. So now again, we're looking for things that are factors that are going to cancel out to be 1. Divide out 1 here and 1 here. We can see x plus 2. We'll divide out with x plus 2. And then we're left with x plus 3 over x minus 2, x plus 1. So give a minute for everybody to catch up to that example. So now we've done simplifying, we've done multiplying, and now we've done dividing. So now we're going to look at adding and subtracting rational expressions. So I'm going to start with 1 over x squared minus 1 minus 2 over x plus 1 squared. Now in adding and subtracting, we have to have a common denominator. So to come up with the common denominator, we have to factor these first. So this is factors into x plus 1, x minus 1, because it's the difference of two squares. This one is going to factor into x plus 1, because that's what squared means as an exponent. So now we're looking for something that'll make these two be the same. So you can see that it's got an x plus 1, this one's got two x plus 1s. So to be the same, we have to multiply this one by x plus 1 in the numerator and x plus 1 in the numerator and x plus 1 in the denominator. Over here now we've got x plus 1, but we still need an x minus 1. So we're going to multiply the numerator by x minus 1, x minus 1. So that gives me my common denominator, x plus 1, x plus 1, x minus 1. So over here, this 1 has to distribute in. Now 1 doesn't change anything, so that case, but in case this had been a 4 or a 5, we need to make sure that we realize that this 1 is going to distribute in. So what comes down is x plus 1. Now this one, the 2 and the negative, they go together, and that negative 2 then distributes in. So I have minus 2x, and negative 2 and a negative 1 would give me plus 2. So now I need to look at the numerator and combine like terms. So I have negative 2x and a positive 1x, negative 2 and a positive 1, subtract and take the sign of the larger gives me negative 1x. 1 plus 2 gives me plus 3. And then the denominator, we put the x plus 1's back together, x plus 1 squared, x minus 1. And then this is my addition, or my sum. Sum is the answer to an addition problem. Okay, the next thing we're going to look at is a compound fraction. Now, what do we see here? We see two fractions. So this top part, we need a common denominator. The bottom part, we're going to write it as h over 1 to make it into a fraction. So compound fraction is a fraction made up of fractions. So in order to put these two together, we have to have a common denominator again. So our common denominator is going to be a times a plus h. So if I need an a times a plus h, for my common denominator, what am I going to multiply this one by? I'm going to multiply by an a in the numerator and the denominator. This one I'm going to multiply by an a plus h. So now I have my a times a plus h for my common denominator. So 1 times a comes down as a, and this minus 1 distributes in, so I get minus a minus h, and this whole thing is still over h over 1. But now you can see what happens. The a and the negative a are opposites, so they're going to cancel out. So I'm left with negative h over a times a plus h. But this bar means to divide. So if I'm dividing by a fraction, then it's the same thing as multiplying by its reciprocal. So now I can see that the h's can divide out from the numerator and the denominator. This negative sign would stay there as a -1. So my final answer is -1 over a times a plus h. Okay, the next thing we're going to look at is rationalizing the denominator and the numerator. Now the one that we've seen the most is rationalizing the denominators, so I start with 1 over 1 plus square root of 2. Now the one that we're most used to is where we just would have 1 over square root of 2, not 1 over 1 plus square root of 2. So in this case we have to rationalize the denominator, which means that we want to get rid of that square root of 2. So what I have to do is I have to multiply by the conjugate in the numerator and the denominator. As long as I multiply a fraction by the same thing in the numerator and the denominator, it's still going to be an equivalent fraction. So what is the conjugate? The conjugate takes the denominator, whatever sign is in the middle, and makes it the opposite sign. So basically you're making it into the difference of two squares, such that when we do the multiplication of these two factors, two binomials, then what's going to happen is the middle term is going to go away, and that's going to cause it to not have a radical anymore. So the numerator, I'm multiplying straight across. 1 times anything would be 1 minus square root of 2. Here we have FOIL. First times each other gives me 1. Outside ones gives me a negative square root of 2. Inside ones gives me a positive square root of 2. And the last one gives me a minus square root of 2 times square root of 2. So this negative square root of 2 and this positive square root of 2 are going to cancel each other out. Square root of 2 times square root of 2 gives me square root of 4. Square root of 4 comes out to be 2. So I have 1 minus square root of 2 over 1 minus 2. So I have 1 minus square root of 2 divided by -1. So 1 divided by -1 is going to give me -1. Negative square root of 2 divided by -1 is going to give me a positive square root of 2. So you have -1 plus square root of 2. So you don't have a radical in the denominator anymore. So now we're going to do the same thing with rationalizing a numerator. So I have square root of 4 plus h minus 2 over h. So now I'm going to again multiply by the conjugate. So I'm going to multiply by the conjugate in this case would be the opposite of this one. So we got square root of 4 plus h plus 2 over square root of 4 plus h plus 2. Now, rationalizing the numerator, we don't do that as much. So in this case, we're trying to get the radical out of the numerator. So the top part then is going to be the FOIL this time. So I have square root of 4 plus h times square root of 4 plus h is square root of 4 plus h squared. So they're going to cancel out and just give me 4 plus h. Outside ones is going to give me 2 square roots of 4 plus h. Inside ones gives me a negative 2 square roots of 4 plus h. So negative 2 and a positive 2 are going to cancel those out. And then you're left with negative 2 times positive 2 gives me a negative 4. The denominator then, I'm going to multiply h times square root of 4 plus h plus 2. And this is where we think it's kind of weird because we're used to not leaving a square root in the denominator. 4 minus 4 is going to cancel out to be 0. So we have h in the top and an h in the bottom, h in the numerator and h in the denominator. So that's going to cancel the h out with the h. So we're left with 1 over square root of 4 plus h plus 2.